In this session, we're going to take a look at using Slate to texture our game character here. We want to open the file character rig start slate.max, and let's just press M to bring up our Slate material editor. Over here in the left, under the material and map browser, I'm just going to scroll down to the sample slots and choose the sample slot that's assigned to this character. So you can see it's this one, standard_7. Not really named the best. We'll say we want an instance of that. And to rename this, we can do one of two things. You can just double click on it and rename it over here. Or you can right click on the node and say rename, which I'm going to do. I'm going to name it char mat for character material. And I'm going to close both of those windows so that I have a little bit more room to work with. So this is the material that's applied to our character, and I'm just going to drag out a diffuse color. I can either go in my custom area or in maps and choose bitmap. And then I'm going to choose this bitmap from the DVD, EOS_D.TGA. This will be our diffuse map. Open that up. And we'll just double click on this guy. And you can even make it a little bit bigger if you want to, so you can see all the details of the head and everything else like that. Now to see this in the viewport, we can click on Show Map in Viewport, and we'll get something that looks a little bit like this. Might be how you're used to seeing textures displayed in the viewport without any hardware shading. And that's what we want to start to use, is some of the hardware shading. So what we'll do is select the material itself, and instead of using the Show Map in Viewport, we're going to click on the flyout and choose Show Material in Viewport with Hardware Map. So then what we should be able to see is our character. I'm just going to take that map away. So here's our character, and you can see the detail level that we have on this character. So we can really see how this would look either in a final render or definitely in-game. We have all the details of the map there because it's being offloaded to the GPU, and we're getting to see that display here in the viewport itself. Now, let's add in some more of these. The next thing I'm going to do is add in a bump map. Now, in order to do that, the first thing I'm going to do is I'm not going to use these controllers a lot. So like we learned before, I'm going to right click. I'm going to go to Show Hide Slots, Maps, or Additional Parameters, and then Maps, and just say Hide All. And that way these guys won't pop up on me anymore. So now what I can do is drag out the bump. And we're not going to use a regular bump, we want to use a normal bump. So go to Maps and choose Normal Bump. And then in the normal slot, let's go to a bitmap. And we're going to choose our normal map, which is EOS_N. And that's going to give us our normal bump. Now you'll see that this, as we're adding maps and the shader gets calculated, this is kind of changing to that checker map as we go through. And that's something important to recognize, but that shouldn't block your workflow from 3ds Max. 3ds Max should kind of operate. You should be able to navigate in the viewport and hear as it's building the shader behind the scenes, which is pretty useful. So we can see that we have our bump map here, maybe not as clear as we might like, so I'm just going to actually disconnect really quick the diffuse color. And now we can really see the detail level that we have with our normal bump map. We have all these details on the character's face, on the horns, the body, the back of the character, and all that stuff is nicely hardware shaded in the viewport here. So we can bring that back up and pipe our diffuse color back in here. So the next map we're going to add in is going to be a self-illumination map, and for that I want to unhide a couple of objects that come with this character. So we'll just go in to the layers, and under the character, just unhide the other objects that are with this character. Its necklace, the lamp, the rope, etc. And we should be able to see those in the scene. So when you come around, we're going to have a self-illumination map that works on all these cryptic little letters and this little light that's inside the character's body cavity that lights it up on the inside, and some stuff that happens on the back here. So in order to do that, we'll go and grab our map. just drag out the self-illumination bitmap and choose that self-illumination map, which is EOS_E. And we'll open that up. I just want to double click on it so that I can make it a little bit bigger and we can kind of see what we have here. So you can see that the light area, the body cavity, and some of these things around the text of the character are there. And I'm going to continually just kind of select the material itself and press C in order to readjust the way that these nodes look here in the view. And if I pan around, we should be able to see that those guys are glowing a little more. We have some in there. And over the back, we have a little bit more glow. But we actually kind of want a lot more than that. So let's double click on the material itself. And what we need to do is set the self-illumination to color. And what that'll do is really give us this nice glow that we can see in the viewport inside the body, around the eyes, and around all these letters here, which is exactly what we want. And we want to be able to see all this stuff in the viewport as we might see it closer to what we might see in the final render or in game. So we can kind of see those things happening here. Now what we'll do is go over and just adjust this slightly. So we have this nice glow in the view. What I want to do is add in something to maybe change the color of that. So I'm going to right click and go to Maps and choose Color Correct. And the Color Correct map, I'm going to drag right onto this wire to insert it. And then I'm just going to go to the material and I'll press C. I'll double click on this map. And then I can adjust things like the tint. So I'm going to go into Tint, change it to something like blue. And then we'll change the strength to 100 and we can see that update in the viewport. So now we can have a blue tint or, and that'll come across all the way over there. Or we can change it to any color we want. So we can get pretty much real-time feedback in the view as to how we want this to look. So I'll change it to, I kind of like the purple or maybe this reddish orange look. We'll go with the reddish orange. And we can take that forward to something like this diffuse map. Let's just go in and rename these maps as well, just so that we're kind of keeping everything tidy. So we'll rename this diff color. And this guy is going to be glow CC for color correct. Normal bump is fine. We'll just rename this normal M for the normal map. And now at least we have those kind of tidied up there. So I can go in and right click and add something else to maybe adjust the diffuse color. So we'll add maybe an output map and just insert that there. Position that and just press C. And I can double click on this and adjust some of the things there. I can also go into just those output parameters and adjust things right here. So if I don't want to be all the way in there and keeping that view pretty heavy, then I can bring these down. And you can use some of your hotkeys too if you're holding down Control or Shift if you want to adjust these that way. So the RGB level, the offset if we want to adjust kind of the saturation or something like that. And if we need access to curves, we can go in and adjust some of those things. So we'll set the RGB level to 1. And with this output map, we can maybe enable the color correct. We'll go with RGB. And just adjust that red so we can bring the red down so that it's not quite as red and we have kind of this greenish character. Or we can beef it up so that there's a little more red hue to it. Whatever we want to kind of adjust for that we can, which is pretty useful. And the last map we'll add is our specular level. So we'll just drag this out. We'll go to bitmap and add in our specular level. We'll let that, and we can see that we can move around the scene while we look at this. And I'll press C just to organize that a little bit better, M to get rid of it. And we can see that we have our character here with the specular level. We'll bring this back up and just double click so that we can adjust the glossiness as well. So if we want this to be more or less glossy, we can. And now we get all those specular highlights on the character. So for now, we're getting a good representation of how this character would look in the final render or in game. And to kind of further this, I want to talk a little bit about adding all these maps and being able to see them here or have them render out via GPU. And that's concerning the file size. Whenever you start creating all these nodes, whatever shaders you add, like this output shader or the bitmap, you're going to need to have enough memory on your video card in order to take care of that and load those shaders as well as textures onto the video card so that you can see them in the scene. And that's something that you want to be mindful of. If you go too far and you run out of RAM, Macs may get unstable or your textures may not show up or something like that. So in that case, it's really important to optimize where you can. One place that's really great to optimize is with these bitmap nodes. Of course, you can make the file size as small as possible, but you can also use a different sort of bitmap node. We have this node here, which you can see has a lot of different parameters under noise and the UV information and the time and output all right in there. There's actually a much simpler node that can be used in order to reduce the wear or reduce the usage on your video card. So in order to do that, we're going to switch over to Mental Ray. Let's just go in here under Common Parameters and assign Renderer. We'll assign Mental Ray. And now when we right click, you'll see we have maps, and we'll have Mental Ray maps as well as Meta SL maps. And the one that we're looking for is this Texture Lookup 2D. If I create that, you'll see that it's really a very simple map or material that you can use in order to replace this bitmap, which is a little bit more intense and will cause to have more instructions on the video card. So I'm just going to double click on this guy, copy, double click here, and paste. And then I'm just going to replace that. Now, you may get some issues here in the viewport. Another thing to remember is when you're trying to reduce this stuff for render, you want to cut out as many of these types of things as you can, the output map and other things like that. So we're just going to bypass this output map to go directly in, and then we'll go through and adjust all the rest of these maps. So you can either shift drag in order to create a copy of this, or you can just right click and create a new one if you want to. And we'll go and just add the rest of these. So I'm going to copy that and paste it in here. Then we'll pipe that result in. And while we're doing this, we may get some anomalies in the viewport. We'll kind of fix those up a little bit later. So again, I'll go in here, add that texture lookup, and this is all just to reduce the amount of memory that we need on our video card in order to supply all this stuff. So I'm pasting that in there. And this wants to go in, pipe it in here to the color correct because we want to keep that. And last but not least will be our bump map. Paste that in there. So if you know that you're going to be doing a lot with the GPU or the Quicksilver renderer or something like that, it may behoove you to use these texture lookup 2D nodes from the very start. And you can see that we have the exact same look here, and we'll get a little bit further with this than we would before. So I'll just press C, and I can also use this hide unused node slots on any of these guys here so that we can just hide these guys and just tidy up the scene a little bit like so. So now we've reduced the memory footprint a bit, And what I want to do is start to work with the in-view lighting. We kind of have our in-view materials all set up and looking really pretty good. So let's go into the lighting scenario. Let's go into the layers and just turn off on the lights layer so that we can see this little environment that we have here. And this has a few different lights that are casting pretty simple 3-point lighting setup. What I want to do is click on the smooth highlights and go to lighting and shadows. You can see I'm using the scene lights. I could also use default lights, and it would go through and kind of calculate those. We'll go back to our scene lights here, and we want to say enable hardware shading. Now by default, pretty much everything will be on, so we'll kind of see our ambient occlusion as well as shadows and other things like that. I want to kind of deconstruct each one of these pieces. So let's go in and just uncheck each one of them. So we don't need exposure control, shadows, or the ambient occlusion. So we'll start off with the ambient occlusion. And to see this a little bit more clearly, what I like to do is just turn these materials off. So let's just go into maps and turn off each one of these. Self-illumination, bump map, and scroll back up. Let's make the diffuse color white. And actually turn off that self-illumination, and let's turn the self-illumination all the way up to 100. And the last thing we're going to do is just set this to standard as opposed to hardware shaded so that we can more easily see the ambient occlusion in the viewport. So now we'll go in, we're going to say ambient occlusion, and let's just do this for all the maps. We'll go to show materials just as a standard display, and we'll be able to see that ambient occlusion happen there. Now normally this will just overlay over your scene, but I wanted to make the material, self-illuminated and use a standard one just so that it's easy to see and tune, and sometimes that works out a little bit better. So, when I go in here, we'll just configure this ambient occlusion. We'll go to lighting and shadows and say configure. And we can decide, the sample radius as well as the quality. We'll set the quality to high, and let's just set that sample radius a little bit higher, maybe 60. And we should see this, really start to smooth out there. So it really depends on how you want to set that up and what you want to get in the viewport. We'll go back here. And I think I'll bring it down to something like 40. And once we're happy with that, we can turn our shaders back on. So we'll just go back into the material. We can set that to color. And just turn all these maps back on. Specular level, self-illum, our bump map. And we'll turn on our hardware with maps as well so we can see those in the scene. And the next thing that we want to turn on is our shadows. So we'll say enable shadows, and then we can see the shadows both on the character as well as on the environment here. And you can see we can move through in real time. They're a little bit aliased, but we can also choose to soften these or get soft shadows. So let's hop in here under lighting and shadows, and we'll say configure. And there's an option to have soft shadows, so we can click on soft, and then we get some nice soft shadows here. So this is pretty nicely detailed. We have our bump maps and our shadows, some ambient occlusion happening here in the viewport, which works out pretty well. And it should give us a pretty good idea of how this is going to render in Mental Ray. So let's hop up into Mental Ray. I'm going to turn off Final Gather because that's not really something that we need at the moment. And we'll render this out. And you can see, for the most part, it looks just as good in the viewport as it does here. We have about a 5-second render time going on with this character. Now, if we want to output this using the Quicksilver renderer, all we have to do is switch over to that renderer. So I actually want to just keep up that last render. So I'm going to go to rendering, and just choose render frame window. And let's duplicate that so that we can kind of take a look at it later. And switch over to Quicksilver. So we're just going to go into the render dialog under common. Same way we switch to mental ray. We're going to choose Quicksilver hardware renderer. And basically what that's going to do is pretty much output what you see in the viewport here to a file sequence. So bring this down and just do a quick render. So what will happen is this will go through and it's done. You can see it took about a second in order to compile the shaders and give us our render, and we can compare this with mental ray. So let's just bring that up and take a look at the difference. So this is our Quicksilver render, this is our mental ray render. You can see for the most part they look fairly close. So are you going to get completely production ready, crazy displacement and super detail renders out of Quicksilver? No, not necessarily. But are you going to get kind of good enough for the middle of production, really nice quality so you can kind of see on those dailies? I think you definitely be able to get that. The one thing that's the most noticeable here in difference, I think, is the anti-aliasing. We don't really have any anti-aliasing here in Quicksilver. So let's just improve that. We're going to go to the rendering tab, and you can see we have hardware-based sampling. So we're going to just choose 2 or 4. We'll choose 2 for right now and re-render that. And you can see that sampling got a little bit better in some areas, and you can even choose 4 times. Now, one thing to remember is this is going to increase the amount of texture size and everything on your video card. So if you don't have enough RAM for that, it's something to watch out for. You can also choose a little bit of software sampling. So a lot of times what I like to do is go and say, maybe we'll use the 2x hardware based and then 4x on software, which is going to give us the 8x sampling, and render that out. We're still at about a second, and if we go in to some of these areas and bring back up our mental ray render, you can see it's really pretty similar to what we had there with mental ray, and we're basically I would say 5 or even closer to 7 or 10 times as fast, which is really pretty good. So I'm going to close that out, and we can go ahead and render out an animation with this. So to do that, I'm just going to create a camera in this view. We'll hit Control C to create a new camera, and then I'm going to select that camera, go to Animation, Constraints, choose Path Constraint, and just constrain it to this path that goes around my character. And now you should see that just kind of circle around. One thing I'm going to do is go into the top view here, and I can just position this target so that it's in the center and it goes around the character. And I'm also going to set my time range to be 0 and 100 so that it loops around. And I think that we'll just raise this camera a bit. So just bring this down so that we can see the character, and just turn on safe frame so we can see what we're getting in the safe frame. Okay, so this is a little wobbly, but I think it'll probably do for a quick camera turnaround. And we want to render this out so that maybe we can send it off for dailies or for something else like that. So we'll go in here and just say we want to render the active time segment. I'm going to save this out just to somewhere on the desktop and click on render. So now what's happening is it's going through, it's rendering frame by frame, and you should see that you get some pretty fast progress out of this. You can really do some fast animation tests that are a little bit more than just those, gray or wireframe renders. You can get some nice lighting, some nice textures, and all those things out of it. And really the big thing to notice is the speed. We have about 33 seconds to render out this entire piece for 100 frames. So that's close to a third of a second a frame. And we get some pretty good quality out of that. Just bring up this video really quick. And we'll play that back. You see, that's pretty good. We got some nice shadows. We got some nice detail on the character. Compression could be a little bit better, but we'll go with that for right now. So for something really fast and quick, works really, really well. You can also add in some other details to this. So if I go over to the rendering tab, there are things like the ambient occlusion, which we looked at, indirect illumination, which does this kind of point light indirect illumination, which is pretty cool, and maybe depth of field. Now, all of these things are going to accumulate with the RAM and the CPU power or GPU power that's on your video card. So you do have to remember that if you start adding a lot of these in, it will make it the render take a bit longer. And on top of that, once you start to reach your GPU power or your RAM limit, things will become unstable in max and even slower. So one thing that's kind of cool to take a look at is the depth of field. We'll choose that, and you can either choose from camera or to override the camera. And this is a nice, fast kind of screen space depth of field effect. I'll go back here, and we won't save this out. I just want to kind of quickly take one fast render of where we are here. And you can see we get this nice blur where the character is really close to the camera and it's focused right back here, which is kind of interesting. And we can take this and render it out as well. So we'll go in here and say our range, and we'll just render this out again. We'll save over what we already had. And even with the depth of field, this doesn't really render that much slower. So you got some nice depth of field effects as well as your shadows and all of those things happening here, which work pretty well. All right, so there, without me talking over it, we actually even reduced the frame time to 30 seconds for the entire thing with depth of field. We'll just pop up this video, and you can see we got some nice depth of field happening in there really pretty quickly. So that's how we can apply some materials to our character using Slate, get the hardware enabled materials in the viewport, and be able to see exactly what our character is going to look like a lot closer to what we might be used to at render time. Tune our lights for our scene in order to light with scene lights and see shadows and things like ambient occlusion in the viewport, and then render those out using the Quicksilver render for a really fast preview. And that's about it on the section for Quicksilver and Slate. And that should hopefully make your preview and in-view experience a lot better in 3ds Max.